Hi all, welcome to this new lecture. So in this lecture we will discuss about Scikit Learn library in Python. Okay, so we'll introduce what is Scikit Learn, then we will discuss why we should use Scikit Learn. We'll talk about its installation, and finally we will give live demo of working with the data set using Scikit Learn library. Okay, so first thing first, what is Scikit Learn? So Scikit Learn is basically an open source machine learning library that supports supervised and unsupervised learning. Okay, so what it comes with, so it provides us various tools for model fitting, pre-processing, model selection and model evaluation, and so many other utilities as well. Okay, so we'll discuss all these in coming lectures using Scikit-learn. But good thing to know that Scikit-learn has a bunch of libraries that help us in building machine learning model from beginning till end. Okay, so you can imagine building machine learning model is a complex process. First you need to collect the data, then you have to pre-process, then you have to choose the model, right? You have to build the model or train the model, and then evaluate and visualize and so many things, right? So scikit-learn comes with libraries for all these things, so that we can just import scikit-learn library and can get access to all those already written codes, and we can just use them. Okay, so that's how machine learning becomes so much easy with the scikit-learn. Okay, so at high level it is very simple and efficient tool. Okay, and it's built on numpy, scipy and matplotlib like libraries. Okay, so numpy is for array processing, matplotlib is for visualization, and most importantly it is open source, so we can just use it for free. Okay, so if you go to this Scikit-learn's their official website scikit-learn.org, so you can see more information about the Scikit-learn. Okay, so at high level it gives that it can be used for supervised learning, which again comes under classification and regression, right? So it also gives what are the different applications and what are the different algorithms that's supported by the scikit-learn library and so on, right? So we will be using most of these algorithms like nearest neighbors, linear regression, logistic regression will actually implement in scikit-learn. But for now, just a reminder that that all these algorithms comes with the scikit-learn library, and it is very easy to use. Same it is for unsupervised learning like clustering, right, data segmentation and so on, and also for dimensionality reduction techniques for visualization, and then model selection and its evaluation process along with the data pre-processing and so on. Okay, so it comes with all these things. Okay, and you can also, if you click on more, you will find tutorials and other information that you can try with. Okay, so let's talk about then installation of this library. So if you go to this install page now, okay, so it gives a good interface where you can select your operating system and then packager. So packager is generally we are using pip, so we'll choose the pip. Otherwise, if you have conda distribution installed, you can choose that. Okay, so for my machine it is windows and pip. So it is very simple command, again like in other libraries, that we can use pip install command, and the library is scikit-learn, and -u is basically one parameter to basically most updated scikit-learn library. Okay, so let me copy that. Okay, so to install that I will go to my command prompt. Okay, and basically once in command prompt I will paste that. Okay, so it should have been pip. Okay, so pip install -u and scikit-learn. Okay, and then I will just press enter. So this library I already have, so I will get these messages saying requirement already satisfied. But in your case, when if you are doing it first time, then it will install all these libraries and you will get successful message at the end. Okay, so now since we have scikit-learn installed in our machine, so let's talk about how to use it. Okay, so very first thing that we will try is working with the dataset. Okay, so for any machine learning application, what we will be operate on data, right? So let's see how we can use one inbuilt data set in the machine in the scikit-learn library, and then we will act upon it. Okay, so for that, the data set that we are going to explore is called iris data set, and that comes with the scikit-learn library. So to tell you background about the data, so there was one scientist, or I think it's statistician. So what he did, he collected the samples of 150 samples of different iris flower. Okay, so that flower looks like this. So it has this sepal and then these petals. So what he did is basically calculated the sepal length and sepal width, right? And similarly for petal length and petal width. And actually there are three categories of iris flower. So based on this measurement, he tried to build a statistical method. Given this sepal length and sepal width, and similarly for petal, can he recognize what kind of category of that iris flower is, and so on. Okay, so this is very famous data set because it is very small and efficient to start with. So we will do the same. Okay, so as we are discussing, the data set already comes with the scikit learn, so we have to just import it. So for that, we in Python we can do like this, right? If from sklearn.dataset, sklearn is our scikit learn, and then datasets class of it, and from there we are importing load iris. Okay, so that is first step. And once we import that, then next thing we will create the instance of that. Okay, so we'll create the instance of load iris as a iris. Okay, so that is our second step. Now if I just print it, so you will see a lot of data here. Okay, so you will see these data array. Okay, and then there are more information under the hood, but let's discuss one by one. Okay, so first we'll just print that data part of that whole iris, okay, object. So if I just print it, so what we are getting here is basically total 150 rows. Okay, and this each row is basically for that four dimension that we discuss about. Okay, so first is sepal length, then sepal width, then petal length and petal width. Okay, so it's basically say for example we have 150 samples, and for each sample of flower, what are those dimensions, that data we have. So it is like numpy array. Okay, or basically like matrix, an array of array, right? So that we have. Now for our human thing, if you want to know what are those features, right? So I can just print iris dot feature names, and we'll get what are these actual features are. Okay, so as we are discussing, first value is sepal length in centimeter, second is its width, third value is petal length and petal width. Okay, so if I give the iris dot feature names, then we get actual names of all those features of the data set. Okay, similarly we have target entity. So if I just do iris dot target, we'll get all these things. Okay, so as we are discussing that there are three types of iris flowers, right? So those are basically these values 0 1 2. So we are getting to know that whatever the target is basically of three kinds. Okay, so for human understanding, of course 0 1 2 we don't understand. So to know the what are these actual targets, we can print that using iris dot target names. Okay, and if I just print that, then we will get that whatever this 0 is basically it's setosa category, and then second is versicolor, and third is virginica. Okay, so just to give an highlight, so what we did, we basically imported this iris data set, right? And then we separate out some important attributes, or the data part of it. Okay, so this iris dot data is giving us all the feature data, in the sense that sepal length, right, sepal widths, petal length, petal widths data, and all these 150 examples, what are those actual exactly values, right? And to know what are those actual names, we can have iris names. Okay, to know the target is in machine learning is what is the true label, right? So we'll get that, and to print that target names, we also have target names attribute. Okay, so this is about the iris dataset. Okay, so not only for this dataset, but for any dataset in the scikit learn, so there are, it needs to meet some conditions. So those are mainly four conditions. One, all data should be numeric. Okay, second, the features and targets, right, that we are talking about, those must be separated. Okay, and those must be numpy arrays, and also their shape should be matched. Okay, so let's discuss one by one. Okay, so in generally machine learning, features we represent by capital X, because generally it is a matrix, right? Matrix of shape m by n. M is number of rows and n is the number of columns, right? So how many examples are there, and what is the value, and what are the different attributes for each example? So we'll have generally matrix kind of thing, right? Here we had, if you see, 150 by 4. So all that data part we are putting into X, and that convention will follow. And similarly for target, we generally give lowercase y, because it is one dimension numpy array. Okay, so we are separating that from our iris. Okay, so that data part, right, that features value we are assigning to X, and we are that target part we are assigning to Y. Okay, so and if we just print X and Y, so if we can see that it's all numeric data, right? It's basically between 0 to some maybe 10 and so on, right? Similarly for Y, so it is again numeric values. Okay, so our first condition met, that all the data should be numeric. And now you might understand that why we have 0 1 2 instead of the string values, right? Even though for humans it is easy to read, but for scikit-learn implementation, all these data should be numeric. Okay, and second condition, that whatever the feature and target have must be of numpy arrays. So let's see that what is the type of our X and Y, and that we can easily find by using this type inbuilt function in Python, right? So if I print that, so we see both are the ND array, so that condition also met. Okay, then third condition is feature and target must be of specific shape. So we can print the shape. So for both X and Y, we have this attribute called shape. So if I give X dot shape, we'll get its shape, and similarly for Y. So let's print that. Okay, so as we know, X is basically 150 by 4, so 150 number of examples, and since we have 4 attributes, right? Sepal length, width, similarly petal length, width, so there are 4 attributes, that's why its dimension is 150 by 4. Okay, and Y is basically of it's one dimensional array of 150 for 150 examples, right? As we can see it here. Okay, so that shape we got. So what is that condition? So these first rows, right, it should match. If there are 150 examples that we are targeting on, same number of true labels we should have it, right? Number of features can vary. For one data set it could be 4, then if we have complex data set it could be more, and so on, right? But this first value or attribute should match for X and Y. Okay, so in our iris data case, all the conditions are matching. So it is first we had well separated our features and target. They are basically of numeric values, they are of type numpy arrays, and also their shapes are matching. Okay, so once we have this kind of proper data set, then we can actually start building on top of it. Okay, so in the next lecture we will build our first machine learning model called k nearest neighbor. But I hope for this lecture you got the basic idea what is scikit-learn is, and how to operate on data sets, and what are the precondition that data must match to be used by scikit-learn. Okay, thank you.